Many of you have gone to cities like Beijing, like Mumbai, even Los Angeles in the 70s and 80s. And the difficulty is obviously, in some cases, seeing the building across the street. The air quality is really bad. It's in many cities around the world. It's not going to go away anytime soon. We have vehicular traffic making a lot of this smog in the cities, and it's actually contributing to um, lung disease around the world, including and especially for the urban poor. So we're waiting on it. So I'll keep talking. So basically what I did was, in a very similar type of conference, we got together with several engineers and we convened to try to think about how to fix this problem. So this is the first slide. We have engineers in aerospace engineering, civil engineering, structural engineering, sustainability. We have public policy people on our team too, because the only way that we think it's going to change is to include policymakers, as well as preventive medicine, because we're looking at areas where the lung cancer or the lung diseases are actually hardest hit. So basically, in the cities, as they get taller and taller, what's happening is these canyons are getting deeper and deeper. And in these canyons, basically, that's where a lot of the particulate matter is sitting. It's sitting because it's heavy, it sits at the bottom, and there's not enough wind to blow it out of there. So it's a problem because that's actually where pedestrians are. It's the worst place possible. My idea, which is fairly radical, especially for architecture and for cities, is actually to think very differently about the liminal facade or the liminal surface of a building. I actually am proposing that the very outside part of the building belongs to the city and not to the owner of the building. That if that surface actually can be designed in such a way to help the public, it can contribute to things like public health and other types of benefits, from filtering water to providing agriculture to hopefully mitigating smog. So in this project that we started to do to try to show how this kind of works with this team is to, again, look at the very bottom of this canyon where the particulate matter sits, where the pedestrians are. The middle zone is actually, again, a mixture of it. It actually is in that in-between area. The top zone is actually where it's very clean air. That's where you get the breeze going up. But as you know, in many of these high-rise buildings, you cannot open a window. It's designed to be efficient, and therefore nobody gets to enjoy that air. What we're trying to do is use that wind that's actually going above, and it provides a circulation of air in these canyons. As you can see, it moves in a downward, upward movement. We combine that with also heat chimney effect, where heat rises naturally, and then we can also get some of that air movement, as well as plunger effect from the vehicles moving around and prevailing winds through the canyons. You can see here in a very quick video, it's kind of, I don't know if you can see it so well, but you actually can see the smoke move around. And what we're trying to do is make these panels for architecture where we use some very simple principles, Bernoulli's principle, Venturi effect, to try to speed up that kind of motion of air so that we can send them through mechanical types of filters, as well as chemically infuse them into the surface itself. Ultimately, what we're trying to do is, again, make this architectural surface so that we can put them on buildings. In this case, we're using what's called a rain screen, which is very common to high-rise buildings, where the facade is actually pulled away from the actual building and use that cavity behind so that the air can move up and pull that air through and filter it. So at the very top, it's then starting to circulate through the canyon again and clean up the air. You can see in some of our early prototypes here, we're working with, again, wind tunnel technology. We're working with simulation modeling. I won't go into a lot of detail about that. You can see here in the next video, if I can get it, you can see hopefully the smoke actually going through the tube and moving through. And so we're trying to find ways to be able to record that. The aerospace engineers is great because they can record and detect Mach speed air movements. But they find this to be a really challenging exercise because we're dealing with air movement that's 3 to 5 miles per hour. I do have right here, I did bring a model just to give you an idea of the scale of some of the things that we work with. A lot of it at this scale is easier because we're able to build it and actually see it. Our intention, though, is not necessarily to be at this scale, but possibly even considering it at a smaller micro and nano scale. And we are looking at arrays of how to do this so that not only is it aesthetically appealing, that it's actually high performing. How can we maximize this on the surface? This next video, you can actually see it also. The smoke that comes out the bottom is separated. It will start to move through the top. And so we're able to get it through the surface. And again, just to give you an idea of scale, this is the model that you see it's actually going through in section as well as elevation. So it's a very different type of porous surface that we're proposing for architecture and to change it. One of our first prototypes that we're trying to build, you see here, is a bus shelter. What we're trying to make is that the shelter would be the freshest air pocket in the city, actually giving it to people who actually spend the most amount of time on the streets. We're working with a team also in trying to figure out fabrication methods. Our idea is to 3D print a lot of these things so that we can infuse titanium oxide and other types of product in there to clean up the gaseous portions of it. As well as make it available anywhere in this world. So that's very affordable. That is not something that is just available to developed countries, but for developing countries as well. So we're looking at using dirt as a product and material for 3D printing to do this. So that is my project. If anyone's interested, we would love any feedback, input, or participation. Thank you very much.